Okay, we've done confidence intervals for proportion, so looky. We're going to do some confidence intervals for our mean. All right, so here are some things that we are looking at. Provided the sample data come from a simple random sample or randomized experiment, the sample size is relatively small based on the population, right? So the same criteria we've had before. N is less than 5% of the population, and the data come from a population that's normally distributed, or the sample size is large. So the data come from this population. That doesn't mean my sample's that big. That just means it comes from a nice big population that is normally distributed, or the sample size is large enough to accommodate. All right, okay. So we are going to look at some percentage of confidence for mean, and it's given by this formula. X bar, which is our point estimate, right, minus, because it's the lower bound, of T alpha divided by 2 times the sample standard deviation over the square root of n. The upper bound is my point estimate plus T alpha divided by 2 times the sample standard deviation over the square root of n. Now, T alpha divided by 2 is a critical, n minus 1 are degrees of freedom. Okay. Think about what we talked about previously, right? When we have a point estimate, that's my middle. I'm going to have a confidence interval that's around the point estimate. That's my cushion that we're looking at, right? My margin of error is going to be that cushion. So this is my margin of error, and E, right? And my point estimate plus or minus that margin of error. Exact same concept. In this instance, however, we have X bar plus or minus my margin of error, because my point estimate here is my mean. All right, so literally the same concept. I'm just talking about a different scenario here, because I'm talking about my mean as that middle value instead of my proportion like what we talked about last time. But it's still, that's in the middle. Whatever my mean is my middle part. And then I'm doing a cushion outside of that for my confidence interval. Okay, now we do have these super sweet formulas here, but we are going to use StatCrunch to do this calculation. However, you still need to understand that this is my point estimate, and then we're giving it the margin of error cushion outside of that point estimate, right? That margin of error plus or minus that E. So if I'm looking at this, then this tells me that I have X bar, and then I have E to get to the upper bound. I have the same amount of E to get to that lower bound, right? That's what we're talking about. Point estimate in the middle. There's that cushion, so I can determine how confident I am in order to pull that off. All right. So we have two options. I'm going to scoot this up a little bit. We have two options, just like we did with our other one in StatCrunch. You can either have it with data or with summary. This one we're going to do with actual data. So if you open up StatCrunch, you can put this data in. This is the exact same 2014 Toyota Camry data. All right, but now we are charged with constructing a 95% confidence interval for the mean miles per gallon of this Toyota Camry, and then we're going to interpret what that means. Okay, so to save us time, I have already put this data in. Boom, there it is. Now this is a T distribution because I'm talking about mean. So when you go to stat, you're going to go to T stats. This is not a proportion. We did proportions before. That was last section. If I'm talking about a proportion, that's where we're going. But this is T distribution. So we're going to go to T stats. And then the same thing, it's one sample. This time I have with data. You have the option of with summary. So I just want you to see what with summary looks like. If you're given the mean, standard deviation, and sample size up front, then you just plug those pieces of information in and you get your confidence interval. All right. We, for this particular problem, have data. So we're going to be looking at our data, and that is in var 1. Let me scoot up this. So there's a lot of information, a lot of things you could pull out of here. We don't need any of that. We are simply doing a confidence interval. And what's my percentage? 95%. So we've already got it. And then we compute that confidence interval. All right. Now, I just want to point something out to you. Let me pull this back over here so you can see what's going on. There's our confidence interval, right? Our lower limit and our upper limit. So over here, do you see that? We figured out our mean from example 1, but look at what our sample mean is. Do we agree? Yes. So I'm pointing this out because we hadn't talked about confidence intervals yet, so I hadn't pulled up StatCrunch, but anytime you have this problem, if you have your data or if you have, if it's given to you in the summary, then you already have that. But you can also get your sample mean from here, just so you know. All right? Okay. So let's swing it back to our current problem, though. We have our upper limit and our lower limit. Upper bound or limit, whatever, is 29.36. Actually, let's write the lower first because I think it makes more sense. Sorry about that. That's why we use pencils, right? It's the beauty of it. Lower limit is 29.37. Let's go to those 2 decimal places just because it makes it nice. And upper is, oh, I did. See, I did it. Oh, for crying out loud in a bucket. So you guys probably hollering at me. You're doing a great job. I'm the one that messed up. 29.37. The lower is 26.83. I got it stuck in my head. Apparently, I don't know what's wrong with me. And we know that our mean is 28.1. So I want to point something out to you here. I'm going to scoot this over just so that we have the full screen of my iPad instead. So what we actually have here is 28.1, and then the cushion associated with that goes up to 29.37 and goes down to 26.83. So your margin of error is in between that, and that is your point estimate. So if we interpret this, we are going to say we are 95% confident. See, we're writing this out exactly the same. I told you it was going to look the same. We are 95% confident, except we're going to say that the mean, instead of proportion here, right? We use the word mean, miles per gallon, of all 2014 Toyota Camrys is between 26.83 and 29.37. So this is that estimate, right? That's the whole title of this section, is we're going to estimate this population, oh, for crying out loud in a bucket. We're going to estimate the population mean is what we're doing. So we're saying based on this sample that we have here, we are 95% confident that all of these cars are going to be between here. So we're 95% confident that our actual parameter is going to be in this interval. So we have our estimate that we have, and then we have our margin of error. based on that. All right, with that 95% confidence. The only thing we're using StatCrunch for is just the actual calculations instead of using these formulas, which we could do, but StatCrunch is going to do the calculations for us. As long as we understand this concept, that's the big deal that I want to make sure you get out of this. Is here is the point estimate. My margin of error sets me here, so we can be 95% confident that my actual population information, the interval for my population, is going to be in there. My mean is. All right? Cool, right?